Hello, fifth grade, and welcome to Module 1 of Science. We're going to begin with Lesson 1. So Module 1 is titled Structure and Properties of Matter. Lesson 1 is Matter's Structures. So we're going to go ahead and begin directly with our pages. Now, when you open up your book, your first pages, as always, are going to be these very first lesson pages where they give you a scenario. You're going to read through it, decide who you agree with the most, and explain why you agree with them. Once you've completed that page, we're going to hop into our next page. Here, we're going to watch a video of an iceberg. So the question you need to answer is what is it made of? And then you need to write down what questions you have about this massive ice in the ocean. So you're going to have to do two separate things here. First, tell what the iceberg is made of, and then write down any questions you have. Let's go ahead and take a look at that video together. All right, now that we've gone through that very quick, short video, we are going to go ahead and write down any questions that we have and write down what we think the iceberg is made of. After you've completed that, we're going to read about the physics teacher in the STEM Career Connection section. And once you've completed reading that, you have two questions to answer. Number one says, what does the physics teacher help students do? And number two, what is a tool physics students might use and how would they use it? So here, please make sure you're using complete sentences when you write your answer. So in order to answer number one, what does a physics teacher help students to do? You're going to pull from your question to form your answer. A physics teacher helps students to, and then you're going to tell me what it is that they help them to do. For the second one, a tool physics students might use is, and you tell me what it is, they would use it for, and then you would tell me what they use it for. Now, we're going to attempt our essential question. I know you don't know the answer to this yet, but I want you to give it your best guess. How are the particles in matter organized? So we're going to learn all of this, so don't worry about having a wrong answer right now. Right now, we're going to give it our best guess, and we're going to learn about it as we go through the lesson. Now, once you've completed these pages, we're going to jump in and we have an inquiry activity. Our inquiry activity is to compare objects. Now, our essential question here that we're going to be focusing on for this activity is, how can you compare different types of matter to determine the structure of matter? So we're going to make a prediction. Remember, that's going to be you giving your best guess. Do heavier objects always take up more space than lighter objects? Explain your answer. Now we're going to go through, we have our list of materials here: safety goggles, a marble, golf ball, table tennis balls, it's a ping pong ball, a pan balance, a graduated cylinder, and 250 milliliters of water. So we're going to be using a beaker instead of a graduated cylinder because the graduated cylinders are really narrow and a beaker has a much wider opening for these different materials. So we're going to measure the mass of each object and record it down here in the table. So this is where your pan balance comes in. You're going to measure in grams. Then you're going to put about 250 milliliters of water into your beaker and note the exact water volume. So when you put it in there, just double check, see exactly how much you have there. And then you're going to place each object in the water one at a time. So you may need to hold it below the surface of the water with your finger, like the ping pong ball, in order to actually, get it to actually go below the water level, because since a ping pong ball is hollow and empty on the inside, it's going to be more likely to float. Then you're going to record the water level after you add each of the objects. Now, the difference between the amount and the original water volume is the volume of that particular object. So we're going to record that in the table as well. So we're going to put down the mass of the object based on what it reads on the pan balance. We're going to look at the water level with the object in it. And then we're going to determine the volume in milliliters of that object. Once you've completed that, you're going to answer your questions. Did the results support your prediction? Why or why not? How are the three objects different? Which object has the most mass? Which object has the most volume? And for number 5, If the table tennis ball were made of the same material as the marble, what property would change? So we're going to go through and answer these questions carefully once we've completed this activity. All right, now that we're done with that, we're going to hop into our textbook and we're going to take a look at some of our vocabulary for this lesson. Your vocabulary words are matter, mass, volume, weight, density, and buoyancy. So let's go ahead and take a look at the definitions of our words. So matter is anything that has mass and takes up space. Mass is the measure and the amount of matter in an object. So how much stuff is it made up of? Volume is the measure of how much space an object takes up. Weight is the measure of the gravitational force on an object. So the weight is based on gravity. Your weight here would be different than your weight on the moon. So weight is a measure of how much gravity is pulling you towards the Earth. Density is the amount of matter in a certain volume of substance, found by dividing the mass of the object by its volume. And we're going to learn more about that later. So density is basically how dense or how close those particles are. And buoyancy is the upward push of a liquid or a gas on an object. So buoyancy is basically, you can think of it as how well it floats. All right, now we're going to read through page 252 in our science handbook. That's your textbook. And we're going to answer the question, what is the difference between mass and weight? All right, let's make that a little bit bigger so we can read it. There we go. Okay, so for this particular answer, we're reading just on page 252. All right, matter. Matter is anything that takes up space and has mass. The water you drink, the air you breathe, and you are all made of matter. Physical properties. A property is a characteristic that you can observe. Scientists describe matter by its properties. Physical properties can be observed or measured without changing what matter it's made of. Color, texture, and size are three of the main physical properties of matter. Mass and weight. Mass is the amount of matter in an object. All matter is made of tiny particles. In general, the more particles an object has, the more mass it has. Think about holding a golf ball and a table tennis ball. This is a ping pong ball. They're about the same size, but the golf ball feels heavier. The golf ball is made up of more particles. It has more mass. As you hold the golf ball and the table tennis ball, you're also feeling their weights. Weight is how strongly gravity pulls on an object. If an object has more mass, it also has more weight. In places where gravity is stronger, such as on Jupiter, an object will weigh more. The mass of the same object, however, will be the same whether it's on Earth or on Jupiter. The mass stays the same because the amount of matter in the object doesn't change. Mass stays the same under other circumstances too. A material's mass doesn't change if you cut it up or change its shape. Okay, so let's recap what we read here. So mass is how much stuff an object is made of, right? So no matter where you are in the galaxy, no matter how much gravitational pull there is or isn't, depending on where you are, the mass stays the same. You're not taking anything away from it. You're not adding anything extra to it. Now, weight is different. Weight depends on the gravity of the place that you're in. More gravity means more weight. Less gravity means less weight. Now, mass, we said, stays the same no matter what you do to it or where you have it. But it also stays the same if you have the mass of a piece of paper. When the paper is flat, it has a particular mass. If you crumple it up into a ball, it will have the same mass. You haven't taken anything away from it or added anything to it. You've just changed its shape. If you fold it up into a paper airplane, it will still have the same mass. So here you can see in the picture example, the mass of a piece of paper does not change if it's flat or folded into different shapes. All right, now that we've gone through that, you can write a nice detailed explanation of the difference between mass and weight and use examples, please, because they do give you plenty of lines to do that. Make sure you're using your best handwriting and complete sentences. All right, next we're going to read pages 254 to 255 and answer these questions after we finish with our reading. What are some properties of matter that can be identified without testing or measuring? What are some properties of matter that are identified by testing or measuring? So some properties that you can identify without testing or measuring. We did read briefly about that, but we're going to read about it some more in our science handbook. So let's go ahead and flip our pages here. So physical properties. All right, physical properties, solubility. The amount of matter to dissolve in a liquid is called solubility. When a substance dissolves, the tiny particles it's made of become too small to be seen. Think about dissolving sugar in a glass of iced tea. It looks like the sugar disappears, but it's easy to tell it's there because the tea tastes sweet. Conductivity. Actually, let's recap solubility before we move on. So solubility is how well something dissolves. A soluble, if something is soluble, that means you can dissolve it, or it can be used to dissolve something. So what happens when it dissolves is those particles break down and they become super small and they blend with the particles around them. Conductivity deals with electricity. So conductivity, electrical and thermal conductivity are two more properties of matter. Electrical conductivity describes how well electricity can move through a material. Metals such as copper, gold, iron, and silver are good conductors of electricity. A conductor is a material that transfers heat or electricity easily. Wood, glass, and plastic stop or slow down the flow of electricity. These materials are called electrical insulators. An insulator is a material that stops or slows the flow of energy, such as electricity or heat. So I want to pause here for a second and explain this. Conductors are really good for having to let heat and electricity pass through it. That's why your wires in the back of your TV for chargers for your devices, the inside of those wires is metal. Now, the outside of those wires has some kind of rubber coating most of the time. And those are insulators because you want the electricity only passing through the wire part and you don't want it passing through you. So that rubber coating that's on the outside of those wires is an insulator that's meant to protect you from basically shocking yourself with that electricity. Thermal conductivity is a measure of how well a material conducts thermal energy. So remember, thermal energy, we're talking about heat. So thermal conductivity, how well can heat pass through something? Thermal conductors allow thermal energy to easily flow through them. Metal pots and pans are good thermal conductors. That's why when you're in the kitchen, you see your mom and dad's pots and pans. They're metal. The part that they cook in is metal. Metal pots and pans are good thermal conductors. They quickly transfer thermal energy from the burner to the food in the pan. Some materials, such as wood, rubber, glass, and plastic, slow or stop the flow of thermal energy. These materials are called thermal insulators. So sometimes you'll see the handle of those pots and pans has a rubber coating, right? And the reason it has that, a rubber coating or maybe a wooden handle, is to basically work as an insulator. So it actually protects and stops heat from flowing all the way through it so that when you hold on to the handle of that pan, you're not burning your hands. Flexibility and elasticity. Objects that can bend without breaking are flexible. A thin wire that is bent into the shape of a paperclip is flexible. Objects can stretch and then return to their original shape are elastic. Rubber bands are elastic. So flexibility is how well does it bend, and elasticity is can you stretch it and have it go back to its original shape. So let's take a look at our pictures here. The beach demonstrates solubility. The taste of ocean water comes from dissolved salts, but the sand does not dissolve. So the salt is already mixed in and dissolved into the water. That's an example of solubility. Electrical wires are often covered with plastic to protect people and objects from the flow of electricity. Those are the insulator parts, the outside rubbery parts. Knowing which materials are conductors and which are insulators of thermal energy can keep you from being burned when cooking. So, for example, if you left a metal spoon in a pot on the stove and the pot was on heat, right? So the stove is on, your pot is on the stove, and you have a metal spoon sitting in there. That metal spoon is going to heat up very quickly because metals are conductors. If you have a wooden spoon sitting in that pot, Your wooden spoon is not going to conduct heat very well. It may get a little bit warm, but it's not going to get hot the way a metal one would, and it won't burn you. All right, other physical properties. There are many physical properties that scientists use to identify materials. Some of these are listed in the table below. Color and shape. Color helps you quickly identify which backpack is yours. The shape of the backpack allows it to fit snugly against your back. Hardness. Hardness is a measure of how resistant a material is to scratching, bending, or denting. Chalk is very soft. It's easy to rub on the sidewalk. Other materials, such as metal or stone, are much harder. Magnetism is the ability of an object or material to be pushed or pulled by a magnet. Some metals, including iron, cobalt, nickel, and nickel are magnetic. Objects can be identified based on whether they are attracted to a magnet or not. Reflectivity. Reflectivity is the way light bounces off of an object. So how well does it reflect light? Smooth, flat surfaces, such as mirrors and shiny pans, reflect light evenly. You can see your reflection in those different kind of surfaces. Rough surfaces scatter light. They do not produce a reflection that you can see. And texture. Texture describes how an object feels. Imagine touching the balls shown here. The basketball would feel rough or pebbly. The soccer ball would feel smooth. Both would feel kind of rubbery. Okay, so now that we've taken a look at these two reading pages, we can go back and start answering our questions. What are some properties of matter that can be identified without testing or measuring? So something you can just identify by basically looking at it. Color and shape, hardness, actually mainly color and shape, reflectivity and texture. Those are easy to identify. The ones you would need to test could be solubility, conductivity, flexibility and elasticity, hardness, magnetism. All of those are examples of ones that you would need to test in order to identify. All right, next we're going to watch a video titled Measuring Matter on Different Ways to Measure Matter. And then we're going to read page 260 and 261 in our handbook and answer the questions after we finish reading. The question we are going to be asked is, how can making observations and measurements of matter help us determine its structure? So let's go ahead and jump into our video.
By now, you probably know how to measure the length of something, or count the amount of money you have. But today, we are going to learn about 3 new types of measurement: mass, weight, and volume. Mass is the amount of matter in an object. If something is made up of matter, it has mass. So the mass, or amount of matter, of an elephant is going to be greater than the mass of a paperclip. We can measure mass using a tool called a pan balance. The units of measurement for mass are grams, abbreviated lowercase g, and kilograms, abbreviated lowercase kg. There are 1,000 grams in 1 kilogram. Weight is defined as the amount of the gravitational pull of an object. It is the measurement of a force. At home, you might use a digital scale to find your weight. We usually measure our weights in units called pounds, abbreviated lowercase lb. What you are actually doing when you weigh yourself is measuring the force of the gravity keeping you on Earth. Scientists also use a tool called a spring scale to measure weight, or the force of gravity on an object. To use a spring scale, you hold the scale upright and connect the hook to whatever object you want to measure. Spring scales measure items in units called newtons. In 1 pound, there are about 4.5 newtons. Finally, let us talk about volume. Volume is the amount of space something takes up, and we can measure the volume of solids, liquids, and gases. We can measure the volume of liquid in tools called beakers and graduated cylinders. We measure volume in units called milliliters and liters. There are 1,000 milliliters in 1 liter. The measurement marks on the graduated cylinder or beaker measure milliliters. If we want to measure how much juice is in our cup, we would pour it into a beaker or graduated cylinder and read the marking where the juice rises and stops. Now you know the difference between mass, weight, and volume.
All right, now that we finished up our video, let's head back and read pages 260 and 261. All right. Let us go ahead and get started here. Observing and measuring matter. Observing and measuring are different ways to identify properties. Senses are used to observe physical properties that do not involve size or amount. You use your ears to hear the sound a harmonica makes when air blows through it. Your sense of taste and smell can be used to tell the difference between a grape and a piece of pineapple, even if you cannot see or feel them. Your sense of sight is used to observe the color of a leaf. Touch helps to tell you whether a spoon is warm or cool. Only properties that can be described by numbers and units can be measured. Measuring is a way to compare size or amounts. People use tools marked with standard units to measure certain properties of matter. A standard unit is a unit of measure that people agree to use. Systems of standard measurement include customary measurement units, such as feet, miles, cups, and quarts. You probably use these units every day, but they're not used by scientists. The system of standard measurement used by scientists is the metric system. The metric system is used every day in most countries around the world. Measuring properties. So we have this table that shows the measurement, the properties of the object, sample units, and sample measuring tools. So to measure length, we're trying to figure out how long an object is. The customary system uses inches, feet, yards, and miles. The metric system uses millimeters, meters, and kilometers. And some measuring tools to do this are rulers, meter sticks, yardsticks, and tape measures. Now to measure volume, that's measuring how much space an object takes up. The customary system uses cups, pints, quarts, and gallons. And the metric system uses milliliters, liters, and cubic centimeters. To measure volume, you can use measuring cups or graduated cylinders or beakers. Now for temperature, you're measuring how warm or cold something is, and the customary system uses Fahrenheit measurement, so degrees in Fahrenheit, and the metric system uses degrees measured in Celsius. So an object or a measuring tool to do this would be a thermometer. Mass is how much matter an object contains. So the customary system will use slugs, and the metric system will use grams or kilograms. And you can use a balance, so a pan balance, to measure mass. Weight is how strong gravity pulls on an object. The customary system uses pounds, and the metric system uses newtons. And to measure weight, you can use a spring scale. All right, measuring mass. Mass is the amount of matter in an object. Mass can be measured on equal pan balance. Gravity pulls on the standard pieces of the sample and on the sample. When the pans are level, the amount of matter in the sample and in the standard pieces is the same. So once it's even on both sides, it's not tipping more towards one side or the other, you know that they're equal. Now to measure weight, weight is how strongly gravity is pulling on an object. So if an object has more mass, it'll also have more weight. Weight is measured in newtons using a spring scale. 1 newton is equal to 225 thousandths of a pound in the customary system. So each newton is 0.225 or 225 thousandths of a pound. Measuring volume. Volume is the measurement of how much space an object takes up. Volume of liquids are often measured in milliliters by using a graduated cylinder, a beaker, or a measuring cup. The volume of a solid is usually measured in cubic centimeters, so that's cm cubed with the little 3 written up like an exponent. A volume of 1 cubic centimeters equals 1 milliliter. A solid that has an irregular shape or is difficult to measure in some way can be measured using displacement. A measured amount of water is placed in a cylinder. The object is placed in the water. The object pushes water out of the way. the water level rises. The original water level is subtracted from the new water level, and the difference is the volume. So what they mean by displacement here is basically what we did in that experiment. So you put a certain amount of water that you're aware of, right? So for the experiment, it was 250 milliliters of water. You take your object and you put it inside that beaker of water or that container of water. Now, the amount that the water level rises minus the original amount that you had in there is going to give you the volume of that particular object. All right, let's go ahead and jump back into our pages. Now, how can making observations and measurements of matter help us determine its structure? So now you can go ahead and answer this question. And then we're going to jump into our digital interactive titled Particles and Matter on how the properties of matter are also related to the structure of its particles. After we explore that, we're going to read pages 256 and 257 in our science handbook and answer the question, compare the particles in the equal amounts of a solid, a liquid, and a gas. So let's go ahead and jump into that activity together.
Use the slideshow to learn about the structure of 3 different types of matter. This cup was made from a combination of metals. It is a solid because it holds a definite shape. It also has a measurable mass, volume, and density. For example, a cup like this might have a mass of 100 grams. Its volume might be 10 cubic centimeters, which is the amount of space it takes up. The density of the metal cup is equal to its mass divided by its volume. So the cup has a density of 10 grams per cubic centimeter. The particles in a solid are closely packed together, which explains how a solid holds its shape and has a higher density than gas and most liquids. The water in this cup is a liquid. It is taking the shape of its container. It also has a measurable mass, volume, and density. Suppose the water has a mass of 200 grams and a volume of 200 milliliters. Liquid water is a special case where its volume and mass are similar. The density of the water would be 1 gram per cubic centimeter. Remember, to find density, you divide the mass of an object by its volume. The particles in a liquid are close together but move freely past each other in its container. This is why liquids do not hold a definite shape. The air in this bottle is a gas. It is filling the space within its container even though the particles can't be seen just by looking at it. The mass of the gas in the bottle would be difficult to measure. However, the volume of the gas depends on the size of the container. The density of a gas depends on the amount of mass within a certain amount of space. The higher the mass and smaller the volume, the higher the density of the gas would be. The particles in a gas are spread out and move away from one another within its container. This explains how gases fill the shape of their container and affect their density at any given time.
All right, so let's go back and review the information that we just listened to. Let's go all the way back. Now, we know solids, what makes a solid is that the particles in the solid are so closely packed together, it doesn't change its shape. It has a higher density, and those particles are really tight together, so that's what makes it solid. They don't move around. For a liquid, it has a lot of particles, but the particles move past each other, and they kind of are free-flowing. So that's what makes it a liquid. It doesn't have a definite shape. Now, for a gas has even fewer particles that just kind of float around past each other. And so they're spread out so far away from each other that this is how they can basically fill the shape of whatever container they're being put into. All right, now let's take a look at those questions. Compare the particles in the equal amounts of a solid, liquid, and gas. You're welcome to go back and rewind this video to re-listen to those sections, but please describe them using complete sentences and details. All right, next, how does the organization of particles in matter relate to the matter's state? So again, these are related to the slides we just looked at. You do not need to do the I can statement on this page. All right, let's move on to our next pages. Now on this page, we're going to read again in our textbook on page 253, and we're going to answer the questions, what is density? How are buoyancy and density related? How do you think you could test an object's buoyancy? And then we've got an activity after that. So let's take a look at pages 253 in our book. Volume, density, and buoyancy. The amount of space an object takes up is its volume. Volume describes how large or small an object is. Volume does not depend on the number of particles in an object. Compare an inflated balloon and a small bag of marbles. The balloon has a greater volume, but the bag of marbles has more mass. The marbles are made up of more particles. So volume doesn't depend on weight or mass. Volume is how much space something takes up. So even though a balloon, after you blow it up, has almost no mass, it's it's not made up of very many particles at all. It doesn't have very much mass or weight. It takes up more space than a marble. Now, a marble would have a greater mass than a balloon, than an inflated balloon, because those particles in the marble are, a marble is fully solid. There's no empty space inside. So all those particles are packed really tightly together. So volume only relates to how much space something takes up. Density is a measure of how closely packed an object's particles are. So it shows the relationship between mass and volume. If you add more marbles to the bag, the marble becomes more closely packed. The density of the bag increases. If you take the marbles out, the density of the bag decreases because there's fewer marbles in there, there's more space in between them. There are many ways you can change the density of a bag of marbles. You can change the volume of the bag. You can add or subtract marble particles, so adding or subtracting marbles from the bag. Most matter is not like a bag of marbles, though. With most matter, adding more material also changes the volume. The relationship between the mass and the volume is fixed, which makes density a useful property for identifying matter. Density also determines whether an object will sink or float. Buoyancy is the object's resistance to sinking. So buoyancy is how well something floats. If the density of an object is less than the liquid that it's placed in, it's going to float. If the object is more dense than the liquid, then it will sink. All right, let's jump back into our pages. So what is density? How are buoyancy and density related? And how do you think you can test an object's buoyancy? All of those are going to be in these 4 short paragraphs here. All right, moving past this, we have another activity about density and buoyancy. We're going to explore the relationship between mass and volume and which determines density. So we're going to explore the relationship between mass and volume, which determines density. You're going to also see how an object's density determines whether it's going to sink or float. Now, first, we're going to hypothesize. How will you know whether an object in the material list is more dense than water? Write an if-then statement. So if something is a particular way, then this is going to happen. So that's how you're going to structure it. So we have our safety goggles, our tank of water, golf ball, table tennis ball, which is a ping pong ball, a marble, and a pan balance. So essentially the same materials that we used in our previous experiment. Now, in the table on the next page, that's going to be this one right here, we are going to record whether our objects, whether you think each object is going to sink or float. Then we're going to test it. So place each one of the materials one at a time in the tank of water. Record your observations as to whether the object sinks or floats. Record the volume of each object. You calculated the volumes of the 2 balls in the marble in the previous activity that we did. Measure and record the mass of each object. You found this in the Explore activity, or you can use the pound balance. So you're going to pull from some of the information we got previously and fill it in here. Measure and record the mass of each object. We did that. Calculate the density of each object. Water is considered to have a density of 1 gram per milliliter. Objects with a density greater than water should sink. Objects with a density less than water should float. So what we're going to do over here, we're going to predict whether each one is going to sink or float. We're going to test it out to see which one actually sinks or floats. We can take the mass from our previous experiment. We can take the volume also from our previous experiment, or we can retest them. And then we're going to divide the mass by the volume to determine the density. All right, then we're going to answer some of our questions. How does calculating the density of each object help explain whether it sinks or floats in water? Now think about what we just read. If the object is more dense than the water, it's going to sink. If it is less dense than the water, it's going to float. Choose one of the objects from the activity. Use evidence from the investigation to explain why it either sinks or floats when you placed it in water. Please make sure you're being descriptive, use details, use complete sentences. You have plenty of lines to give a lot of detail in your answer. All right, once we have completed that, we're going to wrap up our lesson. We're going to take a look at our performance task. So this one is optional. You have 3 paper plates, a marker, 100 small same size objects like buttons, beads, beans, marbles, whatever you happen to use, and some glue. And you're going to basically be designing your own activity. How can you use the materials provided to model the 3 states of matter? You're going to label all 3 plates as solid, liquids, or gas. And then you're going to glue down objects to represent what the particles in a solid look like, what the particles in a liquid look like, and what the particles in a gas would look like. You're going to create a sketch of this and write your description below for each one, so the solid, the liquid, and the gas. And then you're going to answer your questions. Construct an explanation. What does the paper plate represent in the model of each of the 3 states of matter? Which of your models is the most dense? How do you know? Describe how you could use your model to teach younger students about the structure of matter. And then we're going to wrap up with our essential question. Think about the video of the iceberg at the beginning of the lesson. Explain how the structure of matter in the iceberg compares to the structure of matter in the ocean and why the iceberg is able to float. So give it your best answer. Please provide lots of details now that we've gone through everything in our lesson. You don't need to do the I did statement. Once you're done with everything, please make sure you review everything you've learned and prepare for our quiz for lesson 1. If you have any questions, let me know. Otherwise, have a wonderful day. Take care. Bye-bye.